Hello children, let us understand Newton's laws of motion. Newton has given three laws of motion that tell how forces affect the motion of an object on which they work. First law gives the concept of force, inertia and inertial frames. Second law defines force and the third law gives action-reaction force pair concept. First law. As per this law, every material body has a tendency to maintain its state of rest or uniform motion in a straight line. It is quite clear that if a body is at rest, it can be moved by the application of an external force. Though it is not clear why uniform motion in a straight line part is included in the statement. We will understand this when we go through the second law of motion. Now let us understand inertia and inertial frames. Inertia is the tendency of a material body to maintain its state of rest or uniform motion in a straight line. In inertial frames, only the forces acting on a material body are responsible for any acceleration caused in it. Second law. As per this law, the rate of change of linear momentum of a material body is equal to and in the direction of net applied force. Momentum in simple terms means mass in motion. If a material body has certain mass and it is in motion, then it will have momentum. Momentum is a vector quantity and it is represented by letter P and given by the formula P is equal to mv, where m is mass of material body and v is its velocity. If we differentiate both sides of it with respect to time, we get dp upon dt is equal to d by dt of mv. M is constant, so it will be taken out. So right hand side becomes m dv by dt. And we know that dv by dt is equal to acceleration a. Left hand side by definition becomes force F. So we get this formula F is equal to ma. If A is equal to 0, that means applied force F is also equal to 0. Zero acceleration means uniform velocity. That is why it is included in the first law of motion. Third law. As per this law, every action on a material body has equal and opposite reaction on the other body participating in the interaction. If you push a table, table will apply equal and opposite reaction on your hands to resist any change in its position or orientation. Let us understand what is a free body diagram. A free body diagram is a pictorial representation in which a body under consideration is assumed isolated from rest of the system. To draw a free body diagram, it is a two-step procedure. In first step, isolate the body from rest of the system and draw in its actual shape and orientation. In second step, show all the forces, whether they are contact forces or field forces acting on the isolated body. We will draw a couple of FBDs in a while. Meanwhile, let us talk about contact forces and field forces. Field forces. We have read there are three field forces: gravitational force, electrostatic force and magnetic force. In this chapter, we will talk only about gravitational force that acts as weight of a material body. Every material body on this planet experiences a gravitational pull directed towards the center of the earth. On material body, it acts at its center of gravity. It is assumed to work uniformly throughout its volume. That means its center of gravity and center of mass coincide. Furthermore, if the material body is uniform, that means its center of mass lies on its geometrical center. So weight of the body works on its geometrical center. It can be represented in either of these two ways. Suppose this is material body and this is its geometrical center. Then weight can be shown in either of these two ways by vertical arrows. In first figure, head of the vertical arrow coincides with geometrical center. In second figure, tail of the vertical arrow coincides with geometrical center. Contact forces work at each contact point of two bodies as action-reaction pair. For example, tension in a string and normal reaction. Now let us see how to show various contact forces in different scenarios. First contact force that we will consider is normal reaction. Normal reaction always works perpendicular to the surface. Suppose a block is kept on smooth floor. Smooth floor means frictionless floor. We don't need to consider friction between this block and the floor. This is contact area. At each point in this contact area, due to weight of the block, force keeps working vertically downwards. Suppose resultant of all these forces is represented by N. So N is the force due to block on the surface. Applying Newton's third law of motion, floor keeps pushing the block vertically upwards with equal and opposite force. So this force N is the force due to surface on the block. To draw the free body diagram of this block, we need to isolate this block from the system and draw it in its original shape and orientation. Next, we need to show various forces acting on this block. N is the normal reaction that is applied by the floor on this block. W is weight of the block that works at its geometrical center. In this scenario, a sphere is kept on the floor and it touches the wall. There are two contact points. First, where the sphere touches the floor, and second, where the sphere touches the wall. This normal reaction N1 is the force applied by the sphere on the floor, and this normal reaction N1 is the force applied by the floor on the sphere. This normal reaction N2 is the force applied by the sphere on the wall, and this normal reaction N2 is force applied by the wall on the sphere. To draw the free body diagram of this sphere, we need to isolate this sphere from the rest of the system and draw it in its original shape and orientation. Next, we need to show various forces acting on it. N1 is the normal reaction that is applied by the floor on the sphere. N2 is the normal reaction that is applied by the wall on this sphere. W is weight of this sphere that works at its geometrical center. In next video, we will see how to show other types of contact forces and solve some numericals based on FBD. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.